This is the rule number 4. That if in numerator, denominator you have a linear polynomial, you have to put a constant. And if you have a quadratic polynomial, you have to put a linear expression in which the constants are unknown. Okay, the coefficients are unknown, and our task is to determine these coefficients. So let's do one example based on it. Okay, based on these suggestions, and maybe you will do some exercises based on what do you call these suggestions. Okay, so let's do one example based on. So let's see that you have 2x square, you have to integrate 2x square minus x plus 4 divided by x cubed plus 4x. Okay, x cubed plus 4. And I have to integrate it. Do I need to, so the first task would be what? So the first check should be what? If the derivative of denominator is numerator, the answer is no actually. So what would be the derivative of the denominator? So it's going to be 3x square plus 4. So you have a 2x square plus 4, you have an additional term. Okay, so it would be a bit troublemaking if you try to do it through other manipulations. So what should we do? Try to simplify it through partial fraction. So let's take 2x square minus x plus 4, and let's say, for example, factorize the denominator. So what is the obvious factorization of denominator? So it's x times x square plus 4. This is what is the obvious factorization. So what we're going to do now, we will try to write it in the form of a partial fraction actually. So let's write it in the partial fraction. So the first is linear expression, so it's going to be a by x. Okay, so its numerator is going to be 0 degree polynomial, in other words constant, plus here the denominator is x square plus 4, which is a quadratic equation, so the numerator is going to be 1 degree less, which is bx plus c. Okay, and our task is what? To find these ABCs. Once we have it, then you can easily solve the integral actually. Okay, you can easily solve the integral. So what to do? What should be the first step? First step should be, okay, do the LCM of it, x times x square plus 4 and a times x square plus 4 and plus bx plus c times x. Okay, this is what that you're going to get. And then if these two fractions are equal, their numerators should be equal. Ax square minus x plus 4 should be equal to a times of x square plus 4, okay, plus bx plus c times x. Okay, bx plus. And then what is the trick? The trick is, if this is a quadratic equation with some coefficient, try to write this also in the form of such equation and then compare the coefficient actually. So in other words, if I simplify this expression, what it will become, so it's going to be ax square plus 4a plus bx square plus cx. Okay, this is what that you're going to get, and then try to write them in the, so put the x square term together, so you're going to get a plus b x square plus, put the linear terms together, so there is only one linear term, cx plus, what is the constant term? The constant term is 4a, and compare it with 2x square minus x plus 4. So this trick would always work actually, no matter how complicated expression you have. That try to write the right hand side in the, in the form of left hand side, and then make the comparison of the coefficients. So the a plus b is going to be 2 because the coefficient of x square is 2. The cx C is going to be negative 1 because, okay, the coefficient of this is 1. And 4a is going to be really what you call 4. So you can already see that you got two numbers already. So the C is minus 1 and a is 1 actually. So if a is 1, what would be b? So the b is going to be also 2 minus 1, so it's going to be 1 as well. So this means this 2x square minus x plus 4 divided by, this x cube plus 4x can be written as a by x, which is 1 over x plus bx plus c. So it's going to be b is 1, so it's going to be x minus 1 divided by x square plus 4. So now you have got your polynomial in interesting form. And now integrate both sides. Integrate both sides with respect to dx. So what you can do next is really calculate these two integrals separately. Okay? Calculate two integrals separately. So when you're going to calculate the two integrals separately, what will the first integral become? 1 over x dx. So this is what the first integral. I know that it's log of absolute of x. What is the second integral? X minus 1 by x square plus 4 and dx. Okay. Is the derivative of x square plus 4x minus 1? Answer is no. So what we should do? So you can do one thing, that say separate this integral. So x by x square plus 4 dx and minus, so you can break it down, minus 1 over x square plus 4 and dx, and solve these two integrals separately. So x by x square plus 4 dx minus dx by x square plus 4 dx. This integral is simple because we know that what is x square plus a square integral dx. What is the integral of this? The integral of this is tangent square or tangent inverse x upon a plus constant. See, we know it. Okay. So here, if you compare this second integral with 1, your a is 2. So therefore, this will become what? Tangent inverse x divided by 2. Okay, so this is first constant. How can I solve this integral? So for solving this integral, you can make a substitution. Let's do t equal to x square plus 4. So the dt will become 2 dx, 2x dx. Okay, so this is going to be 2x dx. You're going to see you have x dx here, not 2. So you can get it, just multiply and divide by 2. Okay. So what would be the integral finally? What would be the integral finally? The final integral is going to be 1 over 2, and the numerator will become dt and the denominator will become t actually. Okay, this is what it is going to be, minus tangent inverse x upon 2. So what would be this now? So it's going to be 1 over 2 log t. So the log t is x square plus 4. So log of x square plus 4 minus tangent inverse x upon 2. So this is the value of the second integral, this integral. So substitute the value of this integral, the first integral, which is log of absolute of x plus Substitute the value of second integral 1 over 2 log of x square plus 4 minus tangent inverse x upon 2 plus constant c. So this is what is the result actually. Okay. So it makes the complicated kind of algebraic fraction. So the trick of the partial fraction is to turn the complicated kind of algebraic fractions into the simplified ones actually, and then solve the integral. Okay. So these are some of the techniques of integration that we are going to focus on, or at least these are some of the techniques that everyone should, always know actually.